the systems and want to clearly label the direction of these things. Okay, so here let me say let me pick up an element in 3D. So here let me pick up the corner element and put into 3D. So the corner element X, Y, and Z. And right now for this case, we made a cut. Say, for example, here I pick an element is like this. So basically, let me highlight this side corresponding is our cutting side. Okay? So hopefully you can see that clearly. So now for this case, we can calculate the shear stress is in this direction. So hold on a second. Hold on a second. I want to get a very good view of these things. So, so why not let me reproduce the things here. So the element is here, okay? So the element sitting here, and for example here, let me define the corner system per this one. So this is Y, and this is Z. And the axial axis is our x. Okay, so per this viewpoint, sorry, let me redo this one. Per this element, orientation of the elements, let me use the blue one. And x direction. Y directions. Okay, like this one. And we, from this figure, we know the shear stress. This basically right now, this is the YZ plane. Okay. So right now, this is a YZ plane. That means x normal to this direction. So that means this plane. Right now on this plane. The drawing of this one basically is on this side. Right? Okay. On this side, we have the shear stress is in this direction. Okay. So clearly this one is on here. And per our notations, tau, if you remember our notation for this one, this is the shear stress in which plane? In the plane and has a normal to x and pointing to y direction. The first symbol is to symbolize the plane. So that is on x plane pointing to y direction. So this is tau x1. And back to Chris' questions. Let me draw this one more time. So this is the same cross section point A, can we make a horizontal cut? And that's the question. Yes. So if we will be able to make a cut like this, then we can study, we can also calculate the V over IT. So right now for this case, we first calculate the magnitude. So V is like this. The same thing, this is our neutral axis. So tau will be equal to VQ over IT. Then we see how to calculate for this case. The V is the given, okay? And I, the same thing over there. And T is the thickness, the width. And for this case, the width will be from here to here. So that is T. And Q, what is Q? Q basically, for example, we take this shaded area and A multiplied with Y bar. From here, we measure the centroid of that, and then the distance here is Y bar. The same template. Okay? And now, what exactly is the stress? Is this stress the same as this one? We're going to find out. Okay? So now for this one, we calculate the, let me again put into the 3-dimensional drawing. So the cut is here. So right now I put into the 3D drawing. So basically the cutted plane is like this. Something like this one, right? And again, one more time, let me put in a few. Something like this. Okay, looks better. So again, for this case, the bending moment, continue using this example, the bending moment is bent like this. So again, on this area, the net force is still pointing the same thing. That is equal to sigma bending stress dA, like pointing to that direction. So one more time, get into balance. At the bottom of the internal cut, we must expect the force pointing in this direction. So that means the strain stress will be just working like this. Right? So that means the bending stress converted, the strain stress converted will be working like this. Are we good? And now let me draw this component. So that means this component basically is working, strain stress basically working downward, right? And this is called the tau in the x-plane direction, pointing to z direction. In the x-plane, pointing to z direction. So right now for this one, we calculated actually is tau xz. For this case, we've been calculated is tau xy. We are calculating is our different strain stress components. And those topics belong to is called the 3-dimensional the stress, the 3D stress. And most of the time in fundamental mechanics material, we always dealing with we call the plane stress, only 2-dimensional. Okay, so for homework or for any exams, I will specifically tell you which cut you made. Okay, otherwise you have many options, and for super students, then you might give me 2 different numbers and give me explanation why I have a number like this. That would be super. I will give you a large formula. Okay. But again, that is a very good question. If we only consider a point, then you have at least 2 options. And actually, in the way you're extracting the different stress components. Okay. So that is for this one. And then let me repeat the same thing and using the same loading condition, but simply change the cross section for this.